Hey folks, welcome back. This is Joel, and today we'll be talking about FlexVPN, right? So we've already looked at FlexVPN before. We have done the basic site-to-site FlexVPN, where we had routers R1 and R2 over here, and we used SVTI and DVTIs, right, to establish a VPN, right? So this was the hub and this was the spoke, and we also had a very interesting case where the IP over here was dynamic, and we accommodated that by using DVTI on this particular router by using something called as a virtual templates, and we were able to accomplish that, right? So you can check my previous video for that. Now moving on, let's see the other features of FlexVPN, right? The FlexVPN, why do you even call it as a flexible VPN? um, it's because it doesn't mean that we're using virtual template doesn't mean that you call the VPN as a flex VPN, because virtual template has been used, it's an old concept, it's been used since the days of frame relays, right? Flex VPN basically stands for doing different types of VPNs, in the same kind of setup, right? And the flexibility which you get from that, that's why you call that as a flex VPN. And you will know why, in detail today, because what we did here between R1 and R2 was one kind of a setup, right, where we had SVTI and DVTI. Today we will proceed by creating SVTIs between R1 and R5 as well, right? So this is going to be very simple configuration. We are basically going to create SVTI, which we have already studied before, and then we will look at how we can use NHRP. We're going to use NHRP to replicate a DM VPN kind of a setup as well using FlexVPN, right? So let's get started, right? So what we are going to start is we are going to FlexVPN. Okay, so what you're going to start is we're going to do the SVTIs between R1 and R5, right? So let's start with the configuration. Let's have a text file, because it's like a lot of configuration, so as it'll be easier this way. Let me pull the configuration. Okay, so what we're going to do is let's start with um, let's see if there's already some configuration. Yeah, so I already have the configuration from my last video, where we had the DVTI and SVTI set up on this. So R1 already has certain configuration. We can actually have a look at that over here. Right, so we already have a configuration. We have the crypto configuration as well from the first setup. So we are going to add on to this, so let's keep in mind and continue from that. So what we are going to do is start with so since we are doing SVTI, right, we are basically interested in doing SVTI between R1 and R5. Let's start with router R1. The phase 1, right, phase 1 is very important. Now the phase 1, most of it is already configured. I need not configure this again. I'm going to use the same proposal, I'm going to use the same policy. The keyring, okay, let's start with configuring a different keyring now, right? So let's start with that, right? So this is going to be my keyring configuration. So IKv2 keyring KR, let me put this as R1 over here, just to, right? So this is going to be the keyring configuration, right? So KR15, let's call it as KR15, right, between R1 and R5. The peer is R5. The address of the R5 router is 192.1.50.5, right, pretty much over here, which I have already configured. Hope so. Have I? Let me check that. Yeah, it's already there. So I've already configured all the IP addresses on all the routers, so it's already there. And the pre-shared key, right? So keyring configuration, followed by we will have to create a IKv2 profile here, right? So let's do that. So there we go, the IKv2 profile. Let's call the profile as profile15. Match identity remote address is basically the address of the R5, and local authentication is going to be local pre-shared and remote pre-shared. And we are going to again use the keyring local, and the keyring which is going to be attached is KR15, right? Great. What do we do next? phase 2, right? We want phase 2. The phase 2 is probably already there as well, but let me create a new phase 2 with a new name called tset ESP triple S, and we're going to use MD5 as well, right? So once we are done with the phase 2 part, next thing is we have to do the IPsec profile. Remember, we no more use crypto maps. It's kind of like legacy. We use IPsec profile whenever we are using tunnels, right? So we are going to use IPsec profile here. Create a IPsec profile iprof15. Use the IPsec or phase 2 parameter over here, right? And then the IKv2 profile parameter as well, which we created prof15. Right, that's done. Now comes the most important part, the tunnel. Right, so tunnel. So what do we do with the tunnel? So tunnel, let's create a tunnel here because we are talking about SVTI between R1 and R5, so we need to have a tunnel, right? So the tunnel is going to be 1.5. We are not going to use like virtual templates over here because we know for sure that the IP addresses over here are going to be fixed. It is not like this IP address over here which was dynamic, right? So it's going to be fixed. So we're going to use static tunnels. So we need to define an IP address for the tunnel. So it's going to be 192.168.15.1. So this part of the network is 15, right? Probably it is not written. Let me probably write it down so that it doesn't confuse people. Let me write down that. Right, so this network I'm going to use 15, right? Sorry, yeah. So 192.168.15.0 will be this part of the network. The tunnels over here will have that. The source address is Ethernet 0/0, right? On R1, this is going to be my source address. The destination is 192.1.50.5 because it is R5, and the tunnel mode is going to be IPv4, and the IPsec profile which we earlier created over here is iprof15, right? Where is iprof15? Over here. So we attach that to the tunnel. So once that is done, probably let's put in some routing, right? So we need to have some routing. Let's probably put EHRP 100 no auto summary 192.168.15.0, right? Because this is the new network of the this is the new network of the tunnel, right? So yeah, that looks good. You might be wondering why did not I advertise the 10 network, because it is already done, right? So if I have to show you, I can like anytime go and show you show IP. Okay, let's see, show run section EIGRP, right? So we already have what the 10 network and the 192.168.12.0 network from here, so I need not write the tel network once again, right? So that's going to be my configuration on the R1, right? So let me copy all of this and let's run this on R1, right? That's good. Now we have R5, right? So for R5, what do we do? On R5 again, we have the what do we do is, let me probably copy the same thing and do the necessary changes, so that'll be easier. Let me put that, right? That's good. So for R5, the configuration is going to be so the proposal will remain so on R5, I think since R5 is something which we are configuring for the first time, R1 was already used with the setup over here, so there will be the phase 1 configuration. You will have to repeat it from scratch, right? So let me pull the phase 1 configuration as well. Yeah, I think I got it. So this is going to be my phase 1 configuration. So what I'm going to do is on R5, I'm going to have my proposal, right, which is pretty much the same as what we did on R1. The policy 1, prop 1, this also remains the same. The keying will remain the same as in R1, right? KR15, I'm going to use the same password. The peer address will change, will it? Yeah, will it change? Yeah, it will change because it's going to be R1 over here, right? So you need to the peer is going to be R1. So let me probably change this as well, right? KR1 and the R1. Great. The next part is IKv2 profile. Will there be a change? Yeah, the address over here will change, right? So let's change this to 10.1, and rest everything looks good. The phase 2 will remain as well. The IPsec profile, what has happened to the IPsec profile? Yeah, gonna remain the same. The tunnel, right? So the tunnel 15, the IP address of the tunnel will change to 192.168.15.5, right? It was 15.1 on the R1 side, it's going to be 15.5 over here. Tunnel source is same. Tunnel destination will change to 10.1, and the mode will remain same, and the protection IPsec profile is going to be this, right? And the last part is router ERGRP 100. Probably let me also put the 10 network, because I'm pretty sure that is not advertised already, right? So that's my configuration on R5. So let me just quickly pull this up. So that looks good, right? What do we do now? What have we done? So we have actually established R1 R5 tunneling as well, or basically the VPN using SVTIs. You want to check quickly if it is working. Let me do probably let me go down to R1. Maybe let's clear the screen. Probably it's not very clear, right? So let's see. So on R1, do show crypto right. So you can see here there is a tunnel which is going towards R5, right? And we can also ping, and we can check, do ping 10.5.5.5, right? So we have a ping as well working, right? So that looks good. Great. So we have established this tunneling. Now if you observe this, if I have to talk between the spokes here, right, from R2 to R5, it will always have to go to Dubai, or it will always have to go to R1, right? So let's assume that this region is Dubai, this is probably Singapore and London and so on. It will there will be scenarios where it will be not optimal, because if the traffic has always to pass the hub over here, probably it is not a very optical way, right? And you want to test that, we can test that as well. So let's go on my R1 and let's try to again see the trace route, right? So probably let's end this. Let's trace 10.5.5.5. I was on R1, sorry, let me do that from R2, my bad. Let's clear the screen, right? So let me see if there is connectivity from R2 to R5 now. Let's do a ping from R2 towards R5. The source address showing 10.2.2. Yeah, that works, right? Now let's do a trace, right, to see how this is happening. Right, if you see the trace, the packet from R2 is not directly going to R5, it is going through R1. So you see 192.168.12.1 is nothing but the tunnel IP of this R1, right? So it doesn't go directly. All the packets which are either going from R2 to R5 or R5 to R2 will go through the hub, right? The spokes will not communicate directly. So that is one kind of a setup, right, what we saw. So that's why I was trying to tell you guys that FlexVPN is basically provides you that flexibility with doing different kind of configurations, and this is one of them, right? So if you have a business case, if you really want a use case where you want all the traffic to pass through the hub, then you can use this kind of a setup which we did just now, right? You can use SVTI DVTI on one side, SVTI on both the sides, or again you can replicate SVTI DVTI here as well, and do the configurations as that all the packets will pass through the hub. Right? So that is one part. Now the next kind of configuration which I would show you is where you want the traffic to go from the hub, right, uh, to another. You want the traffic to go from the spoke directly to the spoke and not go through the hub, right? So that's what we are going to do. So for that we are going to use the routers R1, R3 and R4, right? So R1 is going to be my hub, and R3 and R4 are going to be my spokes, right? um, yeah, so that's the background. That's what we are trying to do now, right? What do we have here? So also I would say there's one more thing which I would like to highlight is, one thing is, yeah, we are going to talk directly between the spokes, and the other thing is, in my earlier configurations, the tunnel IPs, right, like for example in this particular network the tunnel IP was 192.168.12.0, this was 12.2, this is 12.1. In this network it was 15.192.168.15.0, this was 15.1, 15.5. So all these IPs were manually configured, right? Those IPs were manually configured. But in this particular setup, what we are going to, the flexibility, or FlexVPN provides you that capability or the feature where you can do this tunnel IP configuration sitting at R1, right? You can delegate R1 to go and assign IPs to my R3 and R4. So that's one more point which we are going to see, right? So what are the prerequisites? One thing is, because R1 will be assigning IPs to R3 and R4, authorization is something which is very important. So we are going to use AAA for the authorization purpose. So that's a new configuration piece which you will be seeing now. And yeah, that's it. I think this is the prerequisite for this kind of a setup. So let's get started. Let's start configuring, and we will, I think, get a better understanding. So let's start with R1, right? So remember, we are going to use R1 and R3 and R4, and the idea is we are going to have a direct communication between R3, or the spokes are going to talk to each other instead of the traffic going to hub. That is my main objective, and I'm going to do this using FlexVPN. We have done this using DMVPN before, yes, but we are going to use FlexVPN. Yes, FlexVPN again uses some of the older technologies, I would say, like the IPsec and IKv2 and so on, but it's a whole new thing, right? It is not same as DMVPN. So we are going to use a different approach for this. Great. So let's start with R1. So let's open my configuration here. So let me probably delete this. So let's start with R1. So what do we do on R1? Okay. So let's start with the AAA, right? So AAA is very important. Let's start with the authorization piece, right? So AAA, new model, and we're going to write AAA authorization network, and the default which has to be used is the local authorization. Right now, the next thing is, like I said earlier, the IP addresses for the tunnels R3 and R4 are going to be assigned by my R1, right? Let's define a address space for that. Probably let's use 192.168.134 would do, right? That's a good number, right? Yeah, so we are going to use this particular address space for all the tunnels. So now the idea is R1 is going to assign the IP addresses to R3 and R4 from a particular pool, right? So for that purpose we are going to do this. So we're going to do this thing called IP pool, right? So that's a IP local pool is the command, right? So we have IP local pool. Flex is the keyword. I mean, it's a name you can use, and 192.168.134.5 is the starting IP address, and it can go up till 254. 192.168.134.254. So anywhere in this range, R1 can assign IPs to R3 and R4, right? So that's one interesting configuration, right? So that's done. Now what do we do? We also need to define authorization policy, which is very important because you're doing all this AAA, right? So we need to define authorization policy. IKv2 authorization policy is NHRP. Give any name, right? In this case, because it is this tutorial or this video is more concentrated on NHRP, I'm going to just give the name as NHRP. The pool is basically the flex which we earlier configured, and the route set interface. Okay, so this command is very interesting, route set interface, So what this command does is it will since I told you R1 is the one which is going to assign IPs to R3 and R4, right? So we need a mechanism where each one of them knows about the IPs which have been assigned to each other. So R1 is going to assign the IPs and then also create a static route in my R3, which would explicitly tell that the IP which is assigned towards R1 is 192.168.134 dot in case of R1 it could be 1, right? 134.1. so there will be a static route entry of R1 present in R3 and R4, and similarly the entries or the IP addresses of the tunnels of R3 will be present in R1. Similar is the case for R4. So you will know that once I do the configuration. So let me keep this for now. I will show you explicitly what it means. Great. So that's also, now let's start with the phase 1 configuration. If you remember, we already have the policy, we already have the proposal and the policy from the previous configurations on my R1. So I'm going to skip that. I'm going to use the same proposal. So I'm going to start with keyring directly, right? So the keyring is KR131 134. Let's say the peer is 34. Since the addresses down south can be dynamic, I'm going to use all 4 zeros over here, and we also have a password. Great. So the next piece, what is the next piece? So once we are done with this, then we have the IKv2 profile, which is very important. So we create a profile 134. Again, the remote address we don't know exactly, it could be anything, right? So it could be dynamic, it could be changing, so we're going to use all zeros like a wildcard mask. And authentication local pre-share, authentication remote pre-share, right? The keyring local is KR134, which we defined earlier. The virtual template, right? We define a virtual template 134 here. I will tell you why we are using this in the next step, but we create and we attach it to my IKv2 profile. And the authorization group, right? PSK list NHRP is very important, right? Because R1 is basically assigning IPs to my R3 and R4 down south, so I need to have the authorization group. Okay, now the phase 2 part, I actually need not explicitly do it because I think I've used the phase 2 in other earlier as well on the same router, but probably I'm gonna create it once again, right? No issues there. So phase 2, what is next? So we need to have a IPsec profile now, right? So IPsec profile, let's create iprof 134 set transform set. I'm going to use the transform set of tset over here, and IKv2 profile is going to be prof 134, which I defined over here, right? Looks sane, good. Now comes the interesting concept about the virtual template, right? So the virtual template is basically what we did, like a DVTI, right? We did a DVTI earlier from R1 towards my R2, if you remember, right? We did a DVTI. Probably I can show you the configuration. I have it on my router. Let's see the interface section here, right? So if you see here, we have a virtual template created, right? So similar is the case, we'll be creating the similar kind of a virtual template over here as well, right? Because we really don't know the IP addresses over here. It could change as well, right? The ISP over here can provide a different IP address anytime. So we want to create kind of like a template which would work, right, in any environment, right, in a dynamic IP environment. So while creating a virtual template, first what we create is we create a loopback address. Let's call that as loopback 134, like a dummy loopback address. We are going to assign the IP address of my tunnel over there, right? Because once you create a template, you can't actually assign the IP address. You can't do any manual configuration, right? So we start with interface virtual tunnel 134 type tunnel. This is the type of tunnel, type of virtual template we are defining. The reason why we created the loopback was here because now we can attach the IP address of what we put in this dummy loopback, right? We are able to attach it to the tunnel. Tunnel source is 0/0. The yeah, so IP NHRP network ID is going to be 134. Now this is corresponding to the NHRP configuration. If you remember, we did similar kind of configuration in my DMVPN as well, right? So there is no concept of NHS over here. If you remember over there, we did something like a NHS on a particular router, and then we configured the NHRP configurations on the clients. But on this one, we just, in this FlexVPN, what we do is we just create the NHRP network ID and the NHRP redirect, right? The redirect is basically, is kind of like a feature which helps, which basically tells the spokes that, hey, if you, it tells the spokes that they can reach another spoke directly and not go through the hub every time, right? The first time it would still go through the hub, but then from the second time onwards, the spokes can reach each other directly, right? So that's the reason of redirect, and the tunnel protection obviously has to be put in, right? That looks good. Yeah, so that was the reason of the virtual template. Where's the virtual template? Over here. We created a virtual template over here, and we are basically using it, right, in this way, right? So yeah, so we will have the virtual template set up on my hub route, right? That's good. So once we do that, now comes the routing part, right? Let's do the routing. So on the routing front, we are going to put in the EIGRP, and we are going to advertise this because the rest of the networks of R1 are probably already there, right? So we'll just pull this up and paste it and run it on the router. It's going to be R1. Sweet. So we have this thing set up. We're gonna move and do the configuration on R3 now, right? R3 being one of my spoke here. Great. So for R3, let me use the same thing and do the changes wherever required, right? So what do we do? Where do we start? With R3, let me check if I already have the IP addresses. I think I should already have. Let me check that. Yeah, I have already configured over here, so it's already there, right? So let's start with the first part, which is my authorization, which will still remain the same, right? And the next part, the pool, can be removed because you are getting the IP addresses from the hub, which is R1, and not from the spoke, so pool is not required here, right? So I can probably remove this part as well, right? That looks good. The route set interface part is still required because the IP address of the IP address of the tunnel, once it is assigned by R1, it has to be sent to the other router. So right, that's where this thing comes into picture. IKv2 key ring KR134. So we're going to create a key ring. It's going to be what kind of a key ring? So I think wait, before that, probably because this is the router R3, we did not have any older configuration on it, so we'll have to put in my phase 1 configuration, right? So let's put that. Let's put the phase 1. Yeah, so this is my phase 1 configuration, the proposal part and the policy part, right? Because R3 did not have the configuration earlier. I am putting it right now. So that's done. Now we do the keyring, right? 134, all zeros, and the Cisco 123, right? And this IKv2 profile, how does it look? Pretty much the same, right? This should work. Yeah, that should work, right? So the next part is phase 2 will also remain the same, no changes there. IPsec profile, right, will still remain the same, right? That's good. So IPsec profile is done. Now the next part is the virtual template part. So now here something really fun happens, right? So the first tunnel, just like how we did the DVTI SVTI setup, right? We are going to have one of the tunnel which is required for communicating with my R1 over here, right, for this communication, right? So between R3 and R1. Similarly, another tunnel would be between R4 and R1. So that is going to be this tunnel, right? So which I'm going to configure now. So let me remove this part. From here there's going to be a change. So let's do that configuration of that tunnel, right? So this is going to be my tunnel. So how does that look? So it's my tunnel 134. IP address is negotiated because you're getting the address from R1, right? And the source is going to be Ethernet 0/0. The destination is going to be 192.1.10.1, right? This is going to be the static IP of my this is going to be an IP, the public IP of my hub, and it will always remain constant, right? It will not, it's not dynamic. This IP will still, it is always static. Then we do the NHRP configuration, right? And we tell NHRP shortcut is something which has to be configured on the clients. We saw that even in case of TMVPN. So when we configure NHRP shortcut, right, we are basically telling to initiate this particular virtual template, right, which we are going to configure next. And the last part is tunnel protection, where we put IPsec profile, which we have already defined, right? So when the NHRP triggers, right, let's say we are talking about, let's say we have a packet which has to go from R3 to R4. The first time R3, the packet will go to R1, right, because the next stop on the router of R3 is R1, so it will go up here and the packet will be sent to R4. But R1 will send a request, or will send an update to R3 saying that next time you have to send a packet towards R4, send it directly, right? So when that happens, right, when R1 basically tells R3 that the packet can be sent directly, that's when this piece of the code, or this piece of the configuration gets initiated, right? So NHRP shortcut is actually doing that, right? And the virtual template which we are going to configure now is going to be initiated. So let's pick that up, right? There we go. So virtual template 134 type tunnel. Like we know that we can't put in an IP address under the virtual template, so I'm going to use the tunnel which I created just now, 134, right, for the IP address. And the source we already know, NHRP network ID, and the shortcut 134, and the last part is your tunnel protection, right, which is iprof 134, right? So what did we do? This part of the configuration, right, that this virtual template part is basically for initiating the connection between R3 and R4, right? It basically creates a virtual tunnel, right? So that's what we established here. So we have a tunnel going from tunnel 134 going from R3 to R1, right? And now when R1 tells R3 that next time you can talk to R4 directly, right? So this is how it is. This virtual tunnel is going to be spun up, and these are the configurations for the tunnel, and a virtual tunnel will be initiated between R3 and R4, right? Let me also put in the routing of this, right? The routing for R1 would be, sorry, for R3, right? R3 would be 192.168.134.0 and 10 network, right? This is the tunnel IPs, right? So this looks good. Yeah, so probably let's take this and put it down on my R3 router. There we go. Now if you see, configuration on R4 will be exactly same as well, right? So you see there is no change here, no change in IKv2 policy, there's no change in keyring, IKv2 profile, IPsec transform set, the tunnel as well, right? So and then the last part being the virtual template, initiating the virtual template, right? So all of this looks good, right? So I'm gonna take this and put it on R4 as well, which is this one. right? Does it look good? Yeah, it should work now. But before that, let's see some of the show commands which we might be interested in. So where do we start? Let's first see the static route which I was telling you guys about. Let's start with R1. The command which I was talking to you guys earlier was route set interface, right? What does it do? So for checking that, let's go to show IP route and let's see static, right? So you can see um, the new IPs which were assigned for R3 and R4, which was 134.5 and 134.6. They are present in the routing table of R1 because of the route set command, right? So you can also see the same thing happening on my other R3 and R4 as well, right? Here also you can see the IP of R1 over here, right? You can uh, see that the static, it has been added as a static route in the routing table of R1. Similarly will be the case for R4, right? So that's for something which I wanted to show you guys. Now let me go down to probably R1 and show you if the IPsec or basically the entire VPN is working. Show crypto, IKv2 SA. There you go. We have 4 tunnels, 1 2 3 4, right? So it should work. Which are the 4 ones? One is over here, 1 2 3 and 4, right? So that looks good, right? Let's see if we can ping from R3 to R4 now. Yeah, there you go. It works. The ping works as well, right? So the first time when I did the ping, it would have gone through my R1 because it would, the first time it always goes to the hub, right? But now if I do a trace of the same ping, you can see it won't go through the hub, right? So you can see here when I did a trace out, it told me that it has to go through 192.168 134.6, right? So it did not, excuse me, it did not go to the hub. So this was a another interesting configuration which we did, right? So where we did spoke to spoke communication, and we used NHRP a lot, right? So yeah, those are the 3 various configurations which I wanted to show you guys on FlexVPN. Thank you for watching.